Welcome to this short presentation on the ITW Instinct software process. The value of the Instinct process is to save precious design time, solve design problems early, improve collaboration between design partners, increase profits and cut costs. What does it mean for design and engineering? The goal of this process is to ensure that it actually cuts down the overall design time, and it cuts out mistakes and allows for closer collaboration between all parties. As such, the architect can create an architectural design, pass that to the engineer, estimator or timber frame designer directly, pass it through to the truss designer directly. Each individual section of the overall construction design process are always dealing with the one model. And upon completion of that model and scheduling of all of its data, all the individual pieces can actually be collaborated together. So the trusses can be sent back to the architect. As well, they can be sent to the engineer and the timber frame designer, and their data can go back to the architect, so that at all times the entire building is going to be reviewed. So let's have a look and see what does this all mean and how does it work. So to begin with, we are looking here at a VisionREZ architecturally produced 3D model. This 3D model being produced in VisionREZ, which is a third-party plugin for the AutoCAD architecture software, enables a designer to produce their 3D model in a faster timescale than using general 2D AutoCAD or the default AutoCAD architecture software. The advantage here is that each wall, door and window and roof object knows exactly what its purpose is in the overall process. In order to link this model through to the entire process, we are going to begin by applying a framing master. The framing master takes the architectural model and links it through to a timber frame design software template, which is produced in the hsbCAD timber frame software. As we can see in this case, this has now recreated that 3D model in a new template file, and it has changed the interface that the timber frame designer would be looking at. By using the ITW clone functionality, this allows us to map the correct timber frame components against all the styles used within the architectural process. So a 140 architectural wall style knows that it is to use a 140 by 38 stud. While it's applying all of this data to the model, it is automatically setting out how to frame that model. And as such, all the correct connection details are applied, plus all the necessary opening data specifying headers and cripples. However, for our overall design process, it's very, very important that we design our building from top down. So first thing we're doing here is we're actually turning off the architectural model because we want to see it clearer. Next, we are going to begin our truss process by creating a new job in our management system, which automatically loads a blank template in the Alpine VIEW software. We will then return to our timber frame design model, and within our timber frame design model we are going to export out all of our walls and our roof planes as they have come through from the architectural model into the timber frame software, and this information will be transferred automatically to the truss software and rebuilt exactly as it is within both other design processes. In this view software we will highlight the first floor area and we will lay out our trusses accordingly. As we add our trusses, the software is automatically prompting you for the correct conditions to use at the start and end of your roof. Do you want gables? Do you want a hipped roof? And so on. And based upon the criteria and the values that you have entered, it automatically lays out your trusses and all loose info. Now that we've all of this laid out, we will begin the engineering process. Now what's important to notice here is that as we are engineering our model, all of this engineered information is automatically appearing within the hsbCAD or timber frame design model. The importance of this is that as we are designing our roof, we need to be aware of where our girder locations are so that we can adjust our framing accordingly. If we require a pint load, if a girder is sitting above a window, maybe that window requires an additional or different header or set of grippers. Again, at all times, the data that we are looking at on the View software and the data that sits within the hsbCAD software are always coordinated. In addition, at any time we can continue to do additional work on the View software. So for example, in this instance we've just added in additional bracing to that roof. And if we want to, we can automatically pull back individual pieces from the roof that we've just continued to design. Again, we can specify that it's coming from the Alpine VIEW software directly. And we can also specify how we want it appearing within our group structures so that we can easily turn it on and off within the timber frame model. Once we're picking OK to this dialog, this is now going to the View software and it's pulling in the necessary data. To highlight further this link between both softwares, we're going to take these individual trusses and we're going to go back to the View software and we are going to edit these trusses and change their webbing pattern. So again, within the View software we have numerous tools that we can use. And as we change this pattern and re-engineer this truss to ensure that it will work, as soon as we update this newly engineered web pattern will automatically appear within the trusses within the timber frame model. Now, to continue this process, we may also want to transfer this information out to the architectural model. So as well as having the automated processes to send this data back, it is also possible to manually send a single file which contains all the trusses and all the bracing. We call this file a DXX file. So we're exporting this, called example plot 4. And when we return to our architectural design model. Again, you can see how the interface changes so that the architect only has the necessary tools available to him or her. In this instance, we will turn off the roof object to make it more visible, and we will now import our truss and bracing layout. And this will import all the pieces accordingly. And as seen, this process allows for one piece of building information modeling to be transferred between 3 different pieces of software. So, just to recap, the benefits and the value of Instinct will be to save precious design time, solve design problems early, improve collaboration between the design partners as all partners benefit from the accuracy, and increase profits and cut costs by reducing the overall design time and costly design errors. Thank you for your time.